So what we'll do today, we will write a program in Keil, and we'll load that particular program to Proteus, and we'll simulate that particular program. Okay, so how to build hardware circuit, okay, and how to load a program, and how to validate that particular things, everything we'll see. Okay, so now to do that particular thing, what we have to do, okay, first, so we have to write a program. So I'll just open Keil platform. So last class we have done some memory things, so I'll just close this particular project. Okay, so create a new project. Okay, so create a new project. So just give some name, like square wave, something like that. I just gave square wave generation. Okay, so just save that particular file, and here you have to select the legacy devices. Now I am selecting 8051. Okay, 8051. So what you do, you just come back to the manufacturers. Okay, so here generic 8051 is there. Okay, so different variants are there. See, you should know 8052 is a good no chip, because no internal RAM is 256 bytes, but I'm selecting 8051. Okay, 8051 is selected. No default startup program is selected, so project is created now. So after that, you need to create one program. So what is that program? I just want to create a square wave. Square wave means, let us include, reach, okay, 51.h. So because I'm using 8051, this one. Okay. Then after that, what you do? So int main. Okay. So start your program. Okay. And successful, execution of all the instruction in this particular program will return 0. Okay, return value of the main function is 0. Then you write your code here. Okay, so now what I'll do here, so I'll create one variable. So before that, I'll just save this particular program. Okay, save this as square wave. Okay, .c extension, that is very important. Save it as .c extension, and then add that particular file. Okay, add that particular file into your project space. Okay, right click, add existing file, and square root.c, that is what we have created, and select that particular file. After adding, you see that this is the program. Okay, just compile, just to ensure that you should not get any error. Okay, so if you select any wrong devices, it may throw some error. Now you can see here Rich 51 is loaded. If you double click on that particular Rich 51, almost the memory programming model of that particular 8051 you can see. So what are bit addressing, as well as the special function registers are given here. Okay, so that means directly you can use this particular register without defining that particular register. So directly we can use P0. Okay, directly we can use B. Okay, directly we can use ACC, that is accumulator. Like this, directly we can use DPL and DPH. You see, so like this you can use 8-bit registers. Okay, so that option is there. Okay, so this is what this particular header file defines. Okay, now in this particular program, what we'll do, see, the main program is something like this. I need to generate, square wave continuously. Okay, so inside a while loop, okay, inside a while loop, I need to, keep on doing, high and low. High and low of what? Say some pin. Okay, so if you see the hardware, so what I want to build, okay, so this is your microcontroller. Okay, 8051 maybe. So now there are n number of pins are there in the microcontroller. Among that, I want to take one pin, maybe P0.0. So first pin. So here I want to generate a square wave. I mean, maybe. Okay, so this is how I want to generate. So that means in this particular pin, I want to generate. So this is very, a single bit. Okay. So single bit, it is not a byte. So only one bit is the, one bit I have to use. That means one physical line I have to use. So now to define that particular, one bit in this particular, embedded C, you can use something called S bit. Okay. So S bit is basically the data type to define the variable. Okay. So what is this variable? Okay, square wave pin. Okay, square wave pin. I just given it as SW pin. So SW pin is basically what is that? You just have to define which port is this. So port 0. Okay, so port 0, instead of dot, you use the caret symbol. Okay, P0 dot 0. So what does it mean? Okay, P0 dot 0. So that means you're defining a pin. Okay, you are defining a pin. So that is basically P0 dot 0 pin. Okay, as a SW pin. Now that SW pin is bit addressable. Okay, so bit addressing the pin. Now what I'll do here? Okay, SW pin. Okay, SW pin. Okay, is equal to 1, and SW pin is equal to 0. Okay, so if I make like this, so just to try to debug this particular program, what it does. So if you see this particular program, the pin, the P0.0 pin will become high and low, inside this particular while loop. So while of 1 means, okay, infinite loop. While of 1 means infinite loop. This particular program will execute continuously, correct? So inside this, what you have, 1 and 0. So high and low, correct? So now what you do, so when you load this particular program, so uh, uh, your program will, you'll generate the, square wave at the microcontroller, clock frequency. So now if you want to control over the frequency, then you can use something called delay program. Okay. So delay of, maybe, 1000 milliseconds, something like this. So maybe, I just have to see whether this kind of, you know, yeah, so delay program is not present in default. Yeah, so what we'll do, we'll write a delay program, okay, our own delay. Okay, so delay on, okay, so this is one function I want to write. Okay, so delay on, just pass some parameters. So like how we written the last class. So value, okay, so you just pass, you have to pass some value, maybe 10,000. Okay, so delay of. Okay, so after off, you may have to call one more delay. So here you can see, 25% is the duty cycle. So that is what I want to create. So define those functions here. So how to define the functions, the return value is basically nothing void. Okay, void. Okay, so this is basically delay on function. Okay, so then you are passing, some maybe integer value, integer, some value you are passing. So you are just creating, this particular delay on function and delay off function. So delay on is this basically this. Now what I try to do here, I'll try to create one variable int I. Okay, so for I is equal to 0 to I less than or equal to, okay, less than or equal to value. So this, okay, so I plus plus. Okay, so even you can create a double loop. Okay, so what you can do, you can have like this. Okay, so like this. So to have more delay. Okay, so for j is equal to 0. Okay, so j plus plus. Sorry, j less than or equal to whatever value you're passing. Okay, so you are creating two loops. Okay, so that means this introduces lot of delay. Okay, so this introduces lot of delay. Okay, so now what you can do, you can create the same program with one more name, that is a delay off program. So you created, okay, so you have created this particular program. Now this program is basically square wave generation with a different duty cycle. Okay, so that is what we are done. So now let us test this particular program. So just compile it. Okay, so you should not have any error. Okay, if you don't have any error, then what you do, okay, so even you can debug here. Okay, so now what we'll do, so we'll try to debug. We'll try to debug. Okay, so here one symbol is there. You can go to debug session. Okay, so to test this particular program, just we are using p0 port. Okay, p0 port. Okay, try to run this. Okay, try to run this program. Now you can see it went in. Okay, so it went in. So the delay is too much, I think. Okay, so the program is running, the delay is too much, so I just have to reduce that particular delay time. So that is taking too much time. So what I'm doing, I'll try to see 10,000 into 10,000. So that much delay it is coming. Okay, so 10,000 into 10,000. Okay, so that's why it is a huge delay. So let me reduce that particular delay. So I just created lesser delay. Now I just came to the simulator and I'm trying to run. Okay, so it is running. So still that program is taking too much time. Again, 1000 into 1000, that is also bigger value. So hence, it is taking too much. It is staying at high value. Uh, you know, Now let me, 100 into 100. No, maybe, we should get something here. So yeah, P naught dot zero. That is the pin, right? So any mistake in the program? So this has to toggle. Okay, I'm just escaping from the debug session now. Let me use directly P naught character symbol 0. Okay, so P naught. Okay, 0. I low I'm just making manually, near equal to. Okay, so this is fine. So let me debug this program. So hi, okay. So let me know if I make the complete pin. Okay, say maybe P naught. P naught I'm just making FF 0x FF all values 1 0x 00 all values you know uh, as this. So when I run this, let us see whether that will work. Okay, with the same delay, just running. Maybe 100 into 100, you should get 10,000. 10,000 should not be that bigger value. Is equal to 0. Okay, 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 okay. There, here's the problem. I just given on time delay here, J, na? So J, okay. Then I just have to come back to main program. Okay, so build, go to simulator. Now try to run. Okay, now it is working. Okay, so now it is working. So then our program is correct. Only the thing is that IJ, you should point, na? So try to, if I make any mistake, please inform me so that I can correct that particular program. So here I just gave I only, so that was the mistake. So now what I'll do, I'll just replace this with SW pin, okay, square wave pin, something like that. Okay, now I can have good delay here. So you know uh, the delay which I can now easily see. So build it. Okay, so then after that, try to run. Yeah, can you see here? Okay, so it was on. Okay, and then it became off. Okay, so here if you see, the value is toggling. Okay, so that is basically the P naught dot zero. Okay, so there you are getting the 25% wave, 25% on and 75% off. So that wave is getting generated here. Okay, so in this particular pin, I am not touching any other pin. You see, so that is one observation what you can do. So here square wave is generating, correct? So square wave is getting generated in this particular pin. Okay. So now, okay. So after this in Keil, what you have to do? So you have to go to, so just come out of this particular debug session. Now, the thing is, this program is working. Okay, this program is working. Now, what we have to do? So you have to go to project. There is one option for target. Okay, option for target. Under this, okay, so you have one, uh, what is this output? Okay, so in this particular output, just you have to check this particular create XY. So this one you have to, check. Okay, so you have to select. So after selecting only, you will get X file will be created. Okay, so you can select where that particular object. I mean that X file should go and sit. That also you can select. So copy that particular folder, and also target. Make sure that the frequency of that particular microcontroller, okay, the oscillator frequency what you are setting. Okay, so that is frequency should come here. Okay, so these two things you just have to take care in this particular place. 8051. Okay, so we know that 12 megahertz. So if at all 11.99 megahertz, something like that, you just have to give the frequency here. So this frequency should match with the frequency of the actual hardware. Okay, so output X code you just have to check. Then after that, press OK. Then after that, you just have to click on, okay, so build. Okay, just click on build. So after this build, you just go to that particular directory. Okay, so your build directory. Okay, so when you go to that particular directory, so there will be one C that .x file will be created. Okay, dot x file will come in that particular directory. Okay, so where is that dot x file? Okay, so now if you come here, object. Okay. Yeah, can you see here square wave dot xy? So here that file got created. You see, so this file is got created. Now what we can do? This program you just have to keep it. Okay, so this program is the program which is going and sitting in the actual microcontroller. Okay, so now what I'll do? Okay, so I'll just try to open Keil. Okay, so Keil, what I'll do it from the beginning. Okay, so I'll close all the project. I'll close all the project. So this is the Proteus platform. After installation of the Proteus, okay, so you will get this screen. Okay, so when you open the Proteus, you will get this screen. Then after that, what you have to do, you just have to click on the new. Okay, so give some name. Okay, so something like square wave, something like some name you just give. Then click on next. Okay, so if you want to create a schematic, no, so any template you want to give or create you want to create a new template. So all those things are possible. Just don't select, do not create any schematic. Then now PCB don't create, so you can create it, so after that, otherwise you just select some simple layout. Okay, so default layout I am selecting. So these are all PCB parameters. Okay, so then after that, what you do, firmware, no, say for example some some microprocessor, microcontroller, advanced microcontroller and microprocessor require some firmwares. So, but in our case, firmware not required. So it's a very primitive microcontroller. So then what I'll do? So sorry, schematic I need in my project. No? So I'll just what I'll do. I'll default a schematic. I'll select. Okay, default schematic and default layout. So I'm just I click on the OK. Okay. So now this is what you'll get, empty thing. Now what you have to do, you have to keep the microcontroller. Okay. So microcontroller, to keep the microcontroller, right click on the space and click on the component and from the library. Okay, so you will get this particular screen. So here you type 8051. Okay, so 8051 microcontroller. So now what you click on subcategory 8051 microcontroller. Here you see a lot of ICs will come 8051. You see this is 80C51. Okay, so this is also 8051 microcontroller. Similarly, Atmega. Okay, so Atmega 8051 is also there. And if you see this one, okay, 808 Atmega 89C51. Okay, so this is also 8051 microcontroller. Normally, whenever you are trying to build any project, try to select 89C52. That is also 8051 microcontroller only. Only RAM is 256 bytes. That's one different. And 8 kilobytes are there instead of 4 kilobytes. So normally select this particular thing. Okay, so it's good. So now I'm selecting 8052. Okay, that is also 8051 microcontroller only. Okay, so just select that particular microcontroller and after that, say okay. Okay, then after that, what you do, you place that particular microcontroller in your workspace. Okay, so done. So now what you have done, so you have taken one microcontroller. After that, if you see for main input for the microcontroller power supply and clock frequency. So that is basically the primitive component for the any microcontroller. Now to do that one, so basically clock frequency, clock pulse is basically the oscillator. Okay, so oscillator, you just have to create and you have to give it in the oscillator input terminal for the microcontroller, so that that microcontroller will oscillate at that particular frequency. Okay, so now what you have to do, you have to keep the oscillator. Now what I'll do, I'll just save this particular file. Okay, so then what I'll do, I'll just open one the earlier project. So whatever I recently created. So from there, I'll take the oscillator circuit. Okay. So here, if you can see, okay, so oscillator circuit is there. So this is basically uh, 11.059 megahertz. Okay, so this is the oscillator circuit. So I'm just copying. Okay, I'm just copying and I'm just opening this particular square wave application, that schematic, and I'm just pasting. Okay, so I'm just pasting that particular. Just a second. So this components I'm taking and just trying to place those components in this particular place. Yeah, I think I just have to right click and save it to the clipboard. Okay, I'll take this clock circuit, copy to clipboard, and it's copied, and go to your program. Okay, so I'm just pasting the particular clock circuit. Okay, so now what is now you see here I'm just making some connection here. Okay, then after that, so this is basically the clock pulse. So just do the wiring. Okay, wiring is done. So then what you have to do, so you should know, so I can keep one LED. Okay, so just to capture the square wave, or I can place something like some meters, virtual meters. Okay, so since I am just using the this one, so I can use some kind of oscilloscope. Okay, so place this place that particular oscilloscope. What I have to monitor, I just have to monitor this particular pin. So so what is that, my output is coming at p0.0. Okay, connect that to CRO, virtual CRO. Okay, so in actual, you just have to, you'll be putting it in some the some connectors. So there you will connect normally. Okay, so now here I'm just want to see. So that's why I connected this to some CRO. Okay, so now what I'll do, uh, after this circuit. Okay, so even you can connect some LED also, that is also possible. Now after that, okay, so everything is done. Now what you have to do, double click on this particular microcontroller. There is one option is there, program file. Okay, so you can see here, this is very important, program file. So here you just select that particular X file what you have created in Keil. Okay, so where you kept in that particular objects directory, that X file is present there. Okay, so the X file is there. Select that particular X file and open it and press OK. So that means you are loading that particular program to this microcontroller. Then after that, done. Everything is done. Now what you have to do, you just have to click on the run. Okay, so you just have to click on the run. Now can you see there, the pin is high here. Okay, so this should go to 0. Now what I'll do, I'll just so the only the time, I think. So it, now you can see here that blue color and red color no toggling is happening. Okay, so blue color and red color toggling is happening. That means it is changing. So now the channel selected is this. Okay, so Okay, all settings are fine. Now this is the input. So where is time setting? These are all time settings. Source is this. So this is the time setting. Okay. Hello. ಯಾರು ಚರುಪುರಿ ಒಂದು ನಿಮಿಷ ಕಾಲ್ ಮಾಡ್ತೀನಿ. So just you just have to increase the time so that but time is too high. That's why you are unable to see that high low. I think P0 port I'm using, and it has become low now. Okay, I think I just have to change the frequency. Okay, I just have to create different program. Okay, I just have to reduce the thing, and also I have to uh, change the the frequency 11 point that oscillator frequency is 11.059. Okay, so this is the frequency, and I'll try to reduce this particular delay time, 100 into 100. Okay, yeah, 1000, 10,000. Okay, so okay, fine. So this is fine. So again, I'll build it. Okay, so that came, that program came. Then what I'll do? Okay, I'll stop the simulation. Okay, double click on that. Okay, so again, you have to select the same program. Press OK. Yeah, clock frequency you know na, so 11.059. Okay, so this is the clock frequency that should match. Then after that, click on the run button. So yeah. Now you can see there, that blinking. Okay, so if you see here, it's blinking. So that means that indicates that this program is working. Okay, so open this. So the blinking is happening, but I just have to. Why this display is not coming? I don't know. Simulation progress. Yes. I'm trying to open this particular. So it's running, and the square wave is also coming. I just want to. I'll just place virtual instrument, oscilloscope, and just I'll place and just make a connection of this particular pin. Simulation must be passed. Okay. Now this is here only. So is it already opened? Okay, somewhere we need to enable them. Okay, okay, so not extruded. So this is there. So when I run, so that square wave it is generating, and but I want to view this particular, uh, I want to view this oscillator. Okay. Okay, let it be. So anyway, square wave is coming. That is sufficient. Okay, so now what we have to understand here. Okay, so this is most important. That CRO doesn't matter because anyway that won't come in our product. Okay, so the only thing what you have to observe here is our microcontroller is working, and in this particular pin, square wave is coming. Okay, so that is the one thing what you have to observe. Then after that, what you have to do, so next one is basically this circuit is working in Proteus. Now the next part is what, you stop the simulation and click on this, PCB layout. Okay, so click on this PCB layout and so place all the component. Okay, so place all the component. So this is your capacitor and, put your microcontroller, you see. So just place all your component in the PCB. So this is your capacitor, oscillator capacitor, and all the component, whatever you have in your circuit. So everything, place it in your, board. So then what you do appropriately, wherever you want, try to manually, you know, uh, manually take that particular, what is that, component. Okay, manually take that particular component and place it. Okay, so wherever you want to place it, that's it. Okay. Okay, so just make that arrangement. So this is what I know you want to place this is the place where you want to place, and try to make it follow some standards. Okay, now after this, so after you placed all the component, now if you go to this 3D visualizer, so this is how it looks like, So the components are placed. Now this, what is this circuit? So this circuit is basically the, uh, as a square wave generator, 25% square wave generator. So this is how the components are placed, and physically you can see this is how it looks like. Okay, so the components. Okay, so now what you have to do, so again you have to come back here in the PCB layout. Now here the circuits you have to create. Now so for that, what you have to do, you just have to go to tools. Okay, there is one thing called auto router. Manual router is also there, but I'll come to that. But try to do auto router because circuit is very simple, and you can implement auto router. Just click on begin routing. So that means it creates the PCB layout, appropriately. Okay, so that wiring will be done. Okay, so there should not be any conflict. So that kind of wiring it will create. So after auto routing, okay, routing. So now what you can do, you can come back to this 3D viewer. Now you can see that wiring also came there. So this is how it will be connected. Okay, so this is how it will be connected. So you can see the wiring diagram also is visible here. How that capacitor, connector, every microcontroller, everything connects. Everything is here now. So then you can have the connector to connect DC supply, and then you can have one more connector to take the output from that particular pin. So those two connectors you can keep in this particular PCB board, and you can give it this particular PCB board for the manufacturing. So this is how you can do. So this is how your components will look like. Okay. So hope I'm clear on this particular Proteus. So you have to prepare, summary is that you have to prepare the program using Keil, okay, and save it, generate Xcode, okay, put the text code inside a microcontroller and build appropriate circuit, and design a, place all the components in the PCB layout, and do the routing of the, do the wiring, routing means wiring only, okay. Then just try to visualize that particular things in a 3D viewer. So this much you should know. So next classes we will take up a good example, and we will execute. Any questions on this? Any questions on this? Please do ask.